Good morning, Junior 6. How are you today? Let's start to complete our lesson today, which is called the law of levers. You know from the last video that the law of levers states that the effort force times its arm equal to the resistance force times its arm. Okay? Now we will talk about the law of levers and conservation of effort, or saving the effort. There are some types of levers conserve effort or has mechanical benefits, while some other types of levers don't conserve effort or doesn't have a mechanical benefit. Okay? By applying the law of levers on the three types of levers, we find that you have learned that there are three types of levers: first class lever and second and third class. Let's start with number one, the first class lever. There are three possibilities in this type of levers, which are: number one, if the force arm is larger than or longer than the resistance arm, like this. If the force arm larger or longer than the resistance arm, so the effort force is smaller than the resistance force. By applying the law of levers, if the force arm larger than the resistance arm, so the effort force must be smaller than resistance force. So the first class lever in this possibility conserves or saves effort or has a mechanical benefit. Possibility number two, if the force arm is equal to the resistance arm, like this. If the force arm equal to the resistance arm, so by applying this possibility in the law of levers, so the effort force is equal to the resistance force. So this first class lever in this possibility doesn't conserve or doesn't save effort or has no mechanical benefit. Number three, or possibility number three, if the force arm is shorter than or smaller than the resistance arm. If the force arm is shorter or smaller than resistance arm. So by applying this possibility in the law of levers, so the effort force is larger than the resistance force. So the first class lever in this possibility doesn't conserve or doesn't save effort or has no mechanical benefit. So in the first class lever, the only possibility that saves or conserve effort if the force arm is longer than or larger than the resistance arm. So the effort force is smaller than the resistance force. Okay? So give reason why sometimes the first class lever save effort. Sometimes first class lever save effort because sometimes in the first class lever the force arm is longer than the resistance arm. So the effort force is smaller than the resistance force. Number two, the second class lever. By applying the law of levers on the second class lever. In this type of levers, what is the meaning of second class lever? Second class lever means the resistance between effort force and fulcrum. Like this, the resistance force is between the fulcrum and effort force. So this type of levers always save effort or has mechanical benefit. Why? Because the force arm, the distance between the effort force and the fulcrum is always longer than the resistance arm. The distance between force and effort force and fulcrum is always larger than the distance between the resistance force and fulcrum. So the effort force is always smaller than the resistance force. So this type of levers, all this lever always saves effort or has mechanical benefit. Okay? Give reason, the nutcracker and wheelbarrow, any example of second class lever, why they save effort or have mechanical benefit? Because the force arm is always longer than the resistance arm. Force arm always longer than the resistance arm. So the effort force always smaller than the resistance force. The third class lever, by applying the law of levers on the third class lever, in this type, what is the meaning of third class lever? Let's recap. What is the meaning of third class lever? Third class lever means that the effort force is between the resistance force and the fulcrum. So the force arm, the distance between the effort force and the fulcrum is always shorter than the resistance arm. So the effort force is always larger than the resistance force. So this type of levers don't conserve effort or has no mechanical benefit. This type of levers don't conserve effort or don't save effort or has no mechanical benefit. But all the third class levers and some of the first class levers that don't conserve effort have no mechanical benefit, but they are beneficial in other things, as increasing the distance like manual broom, or avoid dangers like the sweet holder or coal holder or ice holder, like increasing speed like the hockey pad, or accuracy in performance like the tweezers. So they have benefit in other things. Okay? Now let's make a comparison between the three types of lever: first class and second and third class. Okay? In the first class lever, number one, the first class lever, the location of F or O or R, F effort force, O fulcrum, R resistance force. In the first class lever, the fulcrum is between the effort force and resistance force. But the second class lever, the resistance force is between the fulcrum and effort force. But the third class lever, the effort force is between the resistance force and fulcrum. In the first class lever, the effort force arm and the resistance arm, the force arm may be longer than or shorter than or equal to the resistance arm according to the distance. But in the second class lever, the force arm is always longer than the resistance arm. The distance between the effort force and the fulcrum is always longer than the distance between the resistance force and fulcrum. But in the third class lever, the force arm is always shorter than the resistance arm, because the effort force is between the resistance force and fulcrum. So the distance between the effort force and fulcrum always shorter than the distance between the resistance arm, the resistance force and fulcrum. So the first class lever, sometimes or some of them save effort, but the others don't. But in the second class lever, always the second class lever saves effort. But in the third class lever, always don't save effort. Okay? Benefits. What are the benefits of first class lever? Some of them have mechanical benefits, but the others have other benefits as increasing speed or increasing distance or avoid dangers or accuracy in performance. But in the second class lever, because all of them saves effort, so all of them have a mechanical benefits as they save effort. But in the third class lever, they are used to increase speed, increase distance, avoid dangers, and accuracy in performance. Okay, junior 6. Okay, thank you, goodbye.